right, let's do the solution together. So we have V, can you let me know? V equals, as an array, 3, 1, and 5. Then we had I equals 1. Confirm for me, guys. Okay.
Yes.
For J equals V, what you need to do?
I equals I plus 1.
I equals I plus 1.
If I equals 3.
Now if I equals 3, he's
I.
questioning if I equals 3, then if that's true, I would be I plus 1 or 3?
2.
2. Okay. Then M would be as well equals I plus J. M would be I plus J. If I'm blocking you, let me know. And that would end the if statement and another end for the for loop. Now, when you look at it, doesn't matter how complicated it is. You know, the regular statements are no complaint. Like the MATLAB would go from left to right, then he will go down to the next one, left to right, down to the next one, and so on. Where you need to pause a little bit is when you see for, and especially if you see for with a nested if, like for and if within the for. In this case, you gotta pause a little bit, see what's going on, but nothing confusing. Take it in the mind of the computer. How does the computer think? Then you'll be just fine. So here, if I equals 3. Okay, now one thing to keep in mind, you see the if statement. If he didn't put end, I'll be confused. I know if have a condition. So this is the condition of if that you're gonna meet so that you can move to the statement. And here is the statement 1, right? Since he have an end, so this end is for if. We said end is optional for if. If you don't have end, then that's going to be a stupid example from the author or from myself in the exam. Hopefully I'll not do that to you. You'll be confused which is the statement for if. Is it both? Is it one of them? So here he had the end for the if. So both of these for the if statement. That's the first thing to look at. Then we have another end. That's another end for the for loop. So just look at it this way, you'll be good. Now I saw many of you writing down lines like, oh, okay, we have V equals this much, I equals that much. Try to have a table style in case you had something similar in the exam. Table, like similar to what the workspace in your MATLAB is doing. Table is always a good thing. Like we have V, we have I, and we have J, and we have M, I believe. So have it in a table style. Either if it's handwritten or on the computer. Table is always good. Just keep things organized, and I know the way you think it through. Now V equals 3, 1, 5. So as you see in the workspace, V would equal 3, 1, and 5. Now we finish with this one. Now I equals 1. I'll go to I. Now the program or the PC or MATLAB see it as 1. Now for J equals V, V is 3, 1, and 5. So J equals 3, 1, and 5. But since it's a for loop, he's going to go 3, then he's going to go 1, then he's going to go 5. So in this case, G is 3. If you put it 3, 1, 5, I wouldn't take out marks from you. But I mean, the right way is J in this case is 3. Now J is 3. I would equal I plus 1. What's the current value of I? That's 1. 1 plus 1 would make the new I to equal 2. So I would be 2. Now if I equal 3, do all of these. I don't care because it doesn't equal 3, so I ignore until the first end. I go back to the loop. For J equals V, in this case V2, or the second value of V, which is 1. So J would be in this case 1. I would equal I plus 1. The current value of I is what? 2. 2 plus 1, that would make I to equal 3. That's the way MATLAB think it through. Now if I equals 3, that's true. 3 equals 3. I would equal I plus 2. 3 plus 2 would be 5. So the new I is 5. And M, this is the first time we see M. M equals I plus J. So the current value of I plus the current value of J. I don't care about the past. So the current value of I is 5. The current value of J is 1. So that will make M to equal 6. You can put it here or you can put it here. Either or. If you put it 6, that's fine with me. Now you end it. You go back in the loop. You didn't finish. When J equals the third value, V3, like the third value of V, J would equal 5. So cross out the 1, that would be 5. Now I equals I plus 1. What's the current value of I? That's 5 plus 1. That would make I to be 6. Now if I equals 3, I doesn't equal 3, so I don't care about these. I end. No need to go back in the loop because I finished the 3, like J equals V. J equaled 1 and 3 and 5. So I'm done, then I'll finish the program over here. Program design and algorithm development. We said we go through program design process. We did programming MATLAB functions, user design MATLAB functions. Now today we'll talk about MATLAB function y equals f of x. Now together we're going to write a script. Get ready your MATLAB. So first we will have a function y equals f of x. X is the input, as you know, and the system, whatever you put in the f of x, is the output. And we define y as x to the power of 3 with a dot. So if x is an array or a matrix, you can have to the power of 3 for all the components, minus, I believe, 0.95 multiplied by x, then you end your loop. Now let's go together and create in the editor an M file or a script saying y, function y, equals f of x, and y equals x dot to the power 3 minus 0.95 multiplied by x, then you end it. So here it's like what you're doing, you're trying to define as if you have on the paper in your math class, f of x equals x to the power of 3 minus 0.95 x. Then you try to plug in f of 2, so you replace x with number 2 and see what's the value. That's what the program is doing for you here. But you gotta identify a function called y, which have an equation inside of it. You should write the word function y. So you're telling him y is a function equals f of x. Then you define your equation, y equals x to the power 3 then you tell him after that f of 2 to present either in command window right away or within your script. Now we need to create a function that will take the 3 coefficients of the quadratic equation ax squared plus bx plus c equals 0. Now this equation, when you solve it, you'll have 2 roots. So you determine the solution of the equation. You could just use the matrix form to solve this equation. We gotta go with a simple way to do that. Now, if you wanna have a structure plan or a coding plan to create, in this case, we're creating a generalized form to solve any equation, like regardless of the parameters of that equation. So this equation A having the parameter a for the x squared and b for the x and c. So any parameter you put in, like let's say 2x squared plus 3x plus 1, you should be able to solve it. If I say a equals 4 and b equals 2 and c equals 10, he should solve it. So we are creating a generalized solution for the quadratic equation that we see in this form. Now the structure plan or the coding plan, so you will ask the user to input the data a, b, and c. Now we say if a equals 0 and if b equals 0 and c equals 0, then you say the solution is indeterminate. That's from math. Now else, if none of those is 0, then display there is no solution. Else, if x would equal minus c divided by b, then you display x only one root equation is linear. Else, if b squared minus 4ac, then you display complex roots. Then if b squared equals 4ac, then we have x equals minus b divided by 2a. and we display x, which is equal roots. Now, if none of that is true, then we say x equals, or x1 equals minus b. You know that equation, how to determine if the solution would be complex roots or repeated roots or individual roots, right? You following that? You guys know that, right? Like when you have a quadratic equation, to find are the roots going to be complex roots for the solution or repeated roots or single roots? I don't know, I see faces here like, you guys know that? Yeah. Okay. Then we have x2 to equal minus b minus the square root of b squared minus 4ac divided by 2a. Display the solution x1 and x2 and you stop. How are we going to approach that coding-wise? So the equation would look like this: a multiplied by x to the power of 2. That's commented out. It means just only for reference. Plus b multiplied by x plus c equals 0. Your inputs are a, b, c. Now we say, start with if a equals 0 and b equals 0 and c equals 0, display like empty. That would be a space for the first line. Second line would be solution indeterminate. Now else, if a equals 0 and b equals 0, then say there is no solution. Else, if a equals 0, only one root, and the equation is linear. Then you display the x. For x1, the value would be minus c divided by b. x2 would be nan, means undeterminate. Now else, if b to the power of 2 less than 4, display x1 and x2 are complex roots. Then you display x1 and x2. x1 would be following this equation, and x2 would be following this equation. Else, if b squared equals 4ac, that means x1 value would be minus b divided by 2a, and x2 would equal x1. And you say else, you would say equal roots. Otherwise, you would start to test. If x1 equation is minus b plus square root of b squared minus 4ac divided by 2a, display x1 and x2, and you end. Take a, b, and c. So we identified a equal, b equal, c equal. Then quadratic ABC gave you what's the solution for your equation. It's kind of, you built a function called quadratic that have 3 variables. And when you input for him what's a, what's b, what's c, he's going to solve it for you. It can be better. There's way better approaches than this, but it's one of the approaches which work. And this is in your textbook. So I anticipated to keep it in our lecture, even though I'm not very convinced with it. Okay, I think you guys are all good with this one. Now, as a summary, algorithm is a systematic logical procedure that you use to solve a problem. Structure plan, we said the coding plan, representation of your algorithm or pseudocode. And the function and file is a script file that's designed to handle tasks that may be activated whenever needed. Now, assume you had the quadratic ABC, you can call it back whenever possible as long as you mention it somewhere in your code. And you will be able to solve the equation in that case. Now we'll talk about MATLAB functions, common functions in MATLAB, how to import and export data, and how to import and export text, importing and exporting binary data. The objectives of this chapter: enabling you to be familiar with some of the more common MATLAB functions. We will talk a little bit about importing and exporting data in and out of MATLAB workspace using the commands load and save. And we can use the import wizard, which is one in your menus, and the low-level file input and output function, which we talk here binary. Like you can go up to binary, not necessarily as text. Now let's go ahead in our command line and write the command help when. That will show you a list of the function that MATLAB already recognize with their descriptions. You can as well go to help in your MATLAB, and maybe you can type in common functions or functions. Scan through functions. You have abs of x, that's the absolute value of x. If you have x equals minus 1, then you say abs of x, that will give you 1. That's the a cos of x, that's the arc cosine or the inverse cosine of x between 0 and pi. we have a cosh of x, which is the inverse of hyperbolic cosine of x. Then we have the, what I call it as asin, that's the arc sine. We have the a sine, we have the a tan 2, that's the mathematical representation for finding the right angle. Say cosine of theta, sine of theta, and a cotan and tan and all of that stuff. Then we have as well ceil of x. That would be the smallest integer which exceeds x. Let's say we want to round the ceil of minus 3.9. That would give you back minus 3. Ceil of 3.9 will give you 4. Then you can use the command clock to give you the time and date in 6-element vector. Cosine x, cosh, cotan, CSC. Then you have the cumulative sum, like CUM, SUM of x. You can use the command date. exp of x will give you the value of the exponential function e to the power of x. You can use fix of x to round to the nearest integer towards 0. You can use floor of x. You can use log of x to give you the natural logarithmic of x. You have log 10, max of x, mean, min, like those average, min, and max, and all that stuff. We used before the rand. We have the real max, real min, and the rem. Now let's try together x equals minus 1 with an increment of 0.1. That's column, like minus 1, column, 0.1, column 1. Then semicolon, we'll hit enter. Then we say plot x and the absolute value of x. It's like you're plotting x and y. X values would be the x value based on the array we had up there. And the y-axis will be the absolute values of x. And he's telling him use this as the symbol of drawing. Like in the graph, you're going to see like it's like O instead of having a line or a cross. Just you will use the symbol O. Okay, there you go. Now we have a function called, we know that MATLAB identified clock, the word clock. He will, if you say clock in your command window, you're gonna see what's the time at that exact moment. Now let's say you write t equals clock, semicolon, then you say f print f. He gonna start to print, open single quotation, percentage sign, 02.0f. 2 percentage sign 02.0f percentage sign colon percentage sign 0.02 0.0f. Then you say comma t of 4, t of 5, t of 6. He's gonna show you hours, minutes, seconds using that function. When you finish, don't delete it. We're gonna need it. Okay, let's move to our exercise, guys. So you have the t equals clock will give you the clock at that exact moment. It's the same, you know, like this purple, and you continue T4, T5. Previous slide is exactly these two. Same. Now I'm asking you, create a MATLAB digital watch that displays the time in command line for 1 minute or 60 seconds. As you know what you already know, what you're gonna do about it, how you're gonna create a code to do that. And that would be, for those of you who never took a coding course, that would be your first creative code. So we know that t equals clock. If I say display t, you're gonna show me the clock, right? In this way, we use the command fprintf to display the t in a certain format, which is hours, minutes, and seconds. So we'll take the code line fprintf as it is, you know, and I'm telling you, for the solution, keep those as they are. But I want you to show me digital clock. Like let's say in the command line, gonna show me the clock. Then next second, show me the clock all the way up to 1 minute or 60 seconds. What you gonna do for this code? Now, when you hit run for these two lines, you see the clock at this exact moment, right? How are you gonna let him keep showing that to you every second? you already got all the tools needed to create this program. Like in the command line, he's going to show me, okay, it's 4:35 and 20 seconds, 4:35, 21 seconds, 4:35, 22 seconds, or 16:35, 22 seconds. I'm going to reveal it for you and remove the bandages here, but I need you to think about it. How are you going to approach this problem? Now, the first bit of the problem, I said if I run this, I'm going to show the clock this exact moment, right? Now, we need to repeat it 60 times. So there's a 4 involved in the story, right? Now, think about it, repetition. Now, first concept, repetition. I got to repeat this 60 times. What should I write? Tell me. Try. Should we go with 4? For loop? Okay, here's a 4. So this is how the logic you get it when you want to solve a problem like this. So the hint, we gotta still use these. Now for I equals, what do you think? You gotta repeat it 60 times. Now, if you say for I equals 1 to 60, that's the first solution would come in your mind, right? From 1 to 60, he's gonna write at this exact moment, the clock 60 times. This is not what we want. There is a command that you don't know. It let the MATLAB delay for 1 second. Look it up online as if you're at home trying to solve it. There's a command that will let you delay MATLAB for 1 second. And try to remove the bandages here. So for I equals 1 to 60, that's true. But in this case, if you do it this way, and of course, since it's for I, it will end, as you can see here. Now that's going to make the clock for 60 times, but it's for the same exact moment. I don't want that. I want to be clocked in every second with a new time. There's a command that delays MATLAB for 1 second. You can say pause, open parenthesis 1, and close parenthesis semicolon. That will stop the MATLAB from processing for 1 second. And after that, he's going to continue running. Do that, and you should get the time for 60 seconds or a minute. Well, congrats on your first creative program based on what you learned in coding. For importing and exporting data. Now, exporting, in a way or another, means saving. So when you export, you save. Now let's create an array. A equals 1, 2, 3, like 1 space 2 space 3, then semicolon 4 space 5 space 6, semicolon. That's going to create this array looking like that. In what we call it as the ASCII format, then we can save it as a file of mydata.txt. We can use that not by the command window, but by saving, like save space mydata.txt of A, then we have a dash ASCII. That's what we call as the ASCII code. We're going to learn more about it in a second. Now to view it, as you know before, you can say mydata.txt. He's going to show it to you, or type it in directly, either in the editor and run, or in the command window. Now if we want to define what's the ASCII, it's the American Standard Code for Information Interchange. It's a way how to represent to the computer what does at symbol means in a computer language, and what does the P means, Q means, and so on. I gave you already a scientific reading today that you can learn more about the ASCII code in case you didn't hear about it before. It's like every symbol, every letter, either capital or small, is been represented with a group of scientists who are leaders in the field. They said, we're going to represent in the form of 0 and 1. That's the form, what we call as the binary numbers. Computers understand 0 and 1, either on or off. You don't understand anything else. So using the on-off language or 0-1 language, that was the binary code. Then we start to advance, make it closer to the language of humans. We had a convention of ASCII code, which is a little bit better. Like instead of having 001, 00001, and so on, to represent a letter, you start to have it in one number or two numbers. Like you say the code 67 represents hashtag. The code 5 represent the percentage, and so on. You can see here, there is binary, there is the number itself. Let's say 8, there's the binary of it, 1000. The hexadecimal of it is A. Same thing for 9, 10, 11, and 12. Every number, as you see it on the screen, as a number that you can read, have a binary representation that the computer understands, and you have an ASCII code for it. If you need more information, you can see the table over here. We have the ASCII on the left, the character, what's the binary, what's the decimal, what's the octal, what's the hex for it. And even you can see the HTML decimal if you're interested, and description. So for scientific reading, I want you to read the provided ASCII kind of tutorial. Learn more about ASCII and binary code. Write the word MATLAB in binary format and in ASCII format. Let's say we want to change the word name and AME to binary. N would be represented as 1001110. A would be 100001. That's in case we are changing the word name into binary. Then you put them all together in one line. Do the same thing for the word MATLAB. And for the ASCII, N is represented as 78, A as 65, and so on. So I think you get the idea. So I want you to develop a structure plan for the solution of two simultaneous linear equations, x plus y equals 3, 2x minus y equals 3. The solution would be x equal 2 and y equal 1. You make, as we mentioned previously in this lecture, you make an algebraic formula for the solution of the system, which is like ax plus by equals c, dx plus ey equals f. Save your script, of course. Load the script into the editor. Send me your script and a screenshot of your MATLAB screen after loading script.